All right, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to learn how to graph a linear equation given in slope-intercept form. So the fun thing about today is we get to graph. Go ahead and pause the video here if you haven't already and check out these full notes here. You can get those URLs also in the pinned comment or a link in the description. Let's start with a warm-up. So here are some warm-up problems. The first one says, find slope m and y-intercept b given a table and write a linear equation in slope-intercept form. Well, the very first thing we notice is that x and y are not shown. We have to use our knowledge of independent and dependent variables to identify that the independent will be the x-axis and the dependent will be the y-axis. So x and y variables go with those numbers. And we also need to remember that we're going to find the change in x over here by drawing our alligators. So draw your alligators. And the change in y on this side, again, draw your alligators. Okay. So from 0 to 35, that's plus 35. From 35 to 49, that is plus 14. From negative 8 to negative 38, that is minus 30. And from negative 38 to negative 50, that is minus 12. Okay, so we'll skip filling this out just yet. Let's go down here. Let's see if I can get it all in frame. Let's remember this definition of slope. Okay, so one of the definitions of slope says that m is equal to the change in y over the change in x. And that symbol, that triangle, means delta in Greek, and it means change in mathematics. So change in y over change in x, and that equals, we'll compute this twice. So we'll start with negative 30 over 35, negative 30 over 35, and we just need to reduce that fraction by dividing by the GCF of 5 over 5. Okay, so that is equal to negative 6 over 7. And we need to make sure that the other pair of changes are the same. So we'll just do that again. This time negative 12 over 14. Negative 12 over 14. And we want to make sure that this can reduce down to the same constant rate of change, negative 6 over 7. So the GCF of 12 and 14 is 2. So we'll divide by 2 over 2. And that will reduce down to negative 6 over 7. That's good news because these two match. And that's what we want to verify. So now we know the slope. The slope is negative 6 over 7. Let's fill that out here. Negative 6 over 7. And that must mean that the rise, or in this case the fall, is negative 6, and the run is 7. The y-intercept can be identified from the table. Wherever x is 0, that's the y-intercept, so the y-intercept is negative 8. Okay, so the equation in slope-intercept form, y equals mx plus b, well, that'll just be y equals negative 6 over 7 x. And instead of plus b, we'll do minus 8. Minus 8. We don't write plus minus 8. We just write minus 8. So that's the equation. And now if we scroll down a little bit, okay, so then you could go to problem number 2, but when you get to problem number 3, you're asked to write the coordinates of the x-intercept for problem number 1, this one. So we'll go ahead and do number 3 next. Makes sense. So to find the x-intercept, which we don't know from the table, This would be where y is 0. So we do know one coordinate of this. So we know that y will be 0. All right, so that's the y value of the x-intercept. We just need to find this guy right here. So let's show our work here. The way we do this is rewrite the equation. Y equals negative 6 over 7x minus 8. And what you want to do is set y equal to 0. Just put a 0 where you see the y, and then rewrite the rest of the equation. 0 equals negative 6 over 7x minus 8. And now we'll just solve for x. So we'll add 8 on both sides. And then we'll have 8 equals negative 6/7 x. We get rid of the negative 6/7 in front of the x by multiplying by the reciprocal. This is keep flip change. So we'll do negative 7 over 6 on both sides. So we multiply by negative 7 over 6 on both sides. The benefit on the right side is that we can cancel out all of our numbers, leaving just x behind. So now x equals, over here, negative 7 times 8 is negative 56. So I have negative 56 over 6. That can be reduced. Okay, so we'll reduce negative 56 over 6. Negative 56 over 6 has a GCF of 2. So we will divide both the top and the bottom by the GCF of 2 over 2. So negative 56 divided by 2 equals negative 28 over 6 divided by 2 is 3. Now that's an improper fraction. It doesn't help us graph it at all. As a mixed fraction, this is negative 9 1/3. 3 goes into 28 9 times with 1 as a remainder, so negative 9 1/3. And that is equal to negative 9.3 repeating. And that is the x-intercept. This is the x-int. Okay, so we could use either the decimal or the fraction here, but we'll go ahead and put the decimal. Negative 9.3 repeating, comma 0. So if you had to graph the x-intercept, you could graph it there. Okay, let's go back to number 2. Write a linear equation in slope-intercept for a line passing through these 2 points, 0, 5, negative 4, negative 7. And then graph the line. Okay, I'm going to take this in a bit of a different order. So first we need to find the slope. Okay, we got to find the slope of the line. Before I start graphing things, I want to find the slope of the line. I need to label these points x1, y1, x2, y2. Go down here to where I'm showing my work. Down here, and let's find the slope. So in this case, we'll use the slope equation. M equals y2 minus y1 over x2 minus x1. And that's why I labeled those points, so I can just plug it in now. y2 is negative 7 minus 5 over negative 4 for x2 minus 0 for x1. So we'll simplify this. Negative 7 minus 5 is negative 12 over negative 4 minus 0 is just negative 4. And that fraction, negative 12 over negative 4, reduces to positive 3. So the slope is just 3. What else do we know about the line? Well, if we look carefully here, we see that 0, 5, that's the y-intercept because x is 0. So y-intercept has to be 5. So I can also make this note. B equals positive 5. So now I know the slope m, which is 3, and the y-intercept, which is 5, so I have everything I need to write my equation. Let's go up here and write this equation. Y equals, remember we need mx plus b. M is 3x plus b, which is 5. So there's the equation. And now we can graph this equation. I want to do one other thing before we graph it. Number 4 is going to ask us to find the x-intercept as well. So let's go down here to number 4 and find the x-intercept. It says find the 0 or root for the equation in number 2. Hint, the 0 or root is the x-intercept. I want to do this because I actually want to plot this point and show you that this will fall right in line with the 2 points you're already given. So first, let's write y equals, so we're going to write the equation we found, 3x plus 5. Y equals 3x plus 5. Okay, remember we're going to set y equal to 0 when we do this, and then rewrite the rest of it, 3x plus 5. So 0 equals 3x plus 5, and now we just solve for x. Minus 5 minus 5. Okay, so negative 5 equals 3x. Okay, to get x by itself, we divide both sides by 3. And so now we have negative 5 thirds equals the x-intercept, but what is negative 5 thirds? That's negative 1 and 2 thirds. 3 goes into 5 once with 2 as a remainder, so it's negative 1 and 2 thirds, and that equals negative 1.6 repeating as a decimal. So this is the x-intercept. The coordinates of the x-intercept would be negative 1.6 repeating, okay, comma 0. So it wants to know what the root is. What you would write here for the root or 0 is you would write x equals negative 1.6 repeating. Or you could have written this in improper fraction form. It doesn't matter. Okay. Okay, so now I'm going to plot this point as well. This is the x-intercept. I'll plot negative 1.6 repeating on the comma 0. Let's go over here and plot some points. So negative 1.6 on the x-axis, that's going to be somewhere in here. It's kind of hard to plot it accurately. So that's one point. The other point is 0, 5. That's the y-intercept. 1, 2, 3, 4, 5. So we plot this point here. And let me make this bigger. And then we need to plot negative 4, negative 7. So we go to the left 4, negative 1, negative 2, negative 3, negative 4, down 7. So down 1, down 2, down 3, down 4, down 5, down 6, down 1, 2, 3, 4, 5, 6, 7, all the way down here. And I want to be at negative 4, 1, 2, 3, 4. So I want to be right here, this point. Okay, see those 3 points? Now I should be able to bring my ruler in and they should all fall on the same line. Now, this is a hand-drawn graph, so be forgiving, but notice that within the human margin of error, these points all fall on the same line. So what we want to do is draw a line going through those points. Right? So again, you kind of have to, the math is correct. So it's these points all fall on the same line. So we draw the line in. And let's label these points. This is the y-int. This is the x-int. And this is just a point out here, negative 4, negative 7. And we want to label our x-int. Remember that was negative 1.6 repeating, 0. And our y-int, 0, 5. So you label all your points when you draw a line on a graph like this. Okay, so we've done all 4 of the warm-up problems, and we're ready for the new material. as you'll see, we already know most of this. How to graph an equation in slope-intercept form. So here are the steps. First, we identify parts of the slope-intercept form. The general form of the slope-intercept equation is y equals mx plus b. And we want to identify these different components using the proper math language, the proper math vocabulary. So y is, this is 1. You see, so these numbers correspond to these numbers, and we're going to fill out this vocabulary. So what else do we call y? Well, we call it the dependent variable. So dependent variable. And that's y. The equal sign is the equivalence symbol. Equivalence. equivalence, symbol, symbol. And that is the equal sign. And the m, well, that's the slope. Okay, we call that m. It's also called the constant rate of change. So constant rate of change. Okay, point number 4, or line number 4, that's x. So we also call x the independent variable. Independent variable. And that's x. Okay, number 5. So this one's a little bit weird. I mean, I know it's a plus symbol, right? But we want to call this the direction on the dependent axis. In other words, the direction on the y-axis. You know, if it's positive, you're going to be up in the above 0. If it's negative, you're going to be below the x-axis. That's what this means. So we can write in here, open parentheses, can be negative. So it doesn't always have to be a plus symbol. It can be a minus symbol. Can be negative. So really, this is plus or minus. And then we have number 6, which is the y-intercept. Right, this is the point where the line hits the y-axis, intercept. And then we give that b, that symbol. Okay, so let's move on now. Okay, down here in the practice, we're going to match the equation parts to descriptions. The independent variable is x, so I'm going to draw a line here from there to there. The direction on the dependent axis, well, we just covered that. That would be here. So we're actually identifying the parts of a real equation, y equals 7/11 x minus 12. The dependent variable, that's y. The y-intercept, well, that's negative 12. Okay. The equivalent symbol, right here, that's the equal sign. Okay, so vertical change. What is the vertical change? Well, think about it. Rise over run. So rise 7, run 11. So the vertical change would be 7. Okay, that's 7. The rise is also 7. Okay, so we can draw another line here. The rise is also 7. Okay, look at the run. The run would be 11. And the run is also the horizontal change. So if you're going to go, the run is going on the x-axis. So horizontal change is also 11. Okay. So maybe I should put here independent variable. That would be x, direction on the dependent axis, minus dependent variable y, equivalent symbol, equal sign. Okay, slope. Well, the slope was 7 over 11. So that would be 7 over 11. Where the line crosses the y-axis, that's just another way of asking for the y-intercept, and that would be at negative 12. Okay, so we filled that out, and now we are ready to move on to part B. Find another point on the line. So, we need 2 points in order to draw a line. We could also use the y-intercept and the slope, but this is another way. So given y equals 7/11 x minus 12, in other words, the equation we were just looking at, if you plotted the y-intercept at, and then it wants us to tell us what the y-intercept is, 0, negative 12. Identify another point on the line using the slope. So let's see what this is saying. The y-coordinate of the y-intercept, well, what is that? That is the y-coordinate of the y-intercept, right here. This is x and y. So that would be negative 12. Plus the rise. What was the rise? Right here, okay? Because it's rise over run, 7 over 11. So the rise is 7. Okay, so this would be 7. What's negative 12 plus 7 gives us negative 5. We'll call that point y2. You'll see what we're going to do here in a minute. The x-coordinate of the y-intercept, that is 0, plus the run. So the run would be the denominator of the slope fraction, and that would give us 0 plus 11 would be 11. And what I'm claiming here is that the points negative 5, 11, I need to be careful. Whoops. So this is the x-coordinate, 11. The point 11, negative 5, that point will be on the same line that the y-intercept is on, and the x-intercept. Okay, so let's go to the next page here and see what we're going to do with this. We need to transfer some information from the previous page. We're going to draw and label a graph, plot 2 points. We're actually going to plot 3 points, and sketch a line. So the third point we're going to plot is the x-intercept down here, and we'll get to that. I need to transfer the equation from the previous page. That equation was y equals 7 over 11x minus 12. Okay, and we've got 2 points. We've got the y-intercept at 0, negative 12, and that second point that we found, 11, negative 5. Okay, so what we're going to do is draw a graph, and because it's all blank paper here, so we have to use our tools to draw a graph, label it, plot those 2 points, then find the x-intercept, plot that point, then draw a line. And hopefully that line will pass through all 3 points. So we have to think about scale. I need to draw an x-axis that can take me from negative, or a y-axis that can take me from negative 12 all the way up to negative 5. And I need to draw an x-axis that can go from 0 to 11. So, this is a 6-inch ruler. If I go in quarter inches, or even 1/8 inches, I shouldn't have a problem fitting all this on one page. But I will have a problem fitting it all inside this little window here. So let me see what I can do about that. Okay, I know what I'm going to do. I'm going to draw a weird looking graph here. Okay, so here's the y-axis. And instead of, usually put it in the middle, right? Instead of doing that, I'm gonna leave this just in quadrant 4 and kind of go over here and draw in this x-axis right here. And this is fine to do it this way. We're just limiting the view. Okay, so now we need to mark off some dashes here. And you should be doing this with your ruler. What I'm doing is lining up that line underneath the 1 so I can see my blue line underneath the transparent ruler. And now I'm going to go down in 1/8 inches. So down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Should be enough. And then over here on the x-axis, I'm going to line up, see this line underneath the 4 or above the 4? I'm going to line that up on the y-axis so I can see the point, I can see the line through it. I know I'm lined up true, and then I'll go in 1/8 inch increments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I don't know that I'll need more than that. We'll see. Okay, so I've got some, now I need to plot some points. So I've got 0, -12. Let's see here, 0, -12. So that would be 0 on the x, -12 on the y. Okay, so that would be 1, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12. Right there. So this point right here, that's the y-intercept. Okay? Y-int. 0, -12. So the next point, this is point 11, -5. So I'll go 11 on the x and down 5. Let's get the down 5 part done. Down 1, 2, 3, 4, 5. So I'm going to be on this plane here. Now I need to go over 11 on the x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right here. Okay, so this point. Now before I plot this in, I want to find the x-intercept. I want to know where this line will eventually cross the x-axis before I draw it in. Because look, very small changes in where I put this ruler, okay, will have big changes in where this thing crosses the x-axis. So I want to be sure I'm putting it in the right place. It says find and label the coordinates of the 0 or root of the linear equation shown above. In other words, find the x-intercept. So what I need to do is rewrite my equation. Y equals 7 over 11 x minus 12. Remember, I'm going to set y equal to 0. Okay, and then just rewrite the rest. Equals 7 over 11 x minus 12. Okay, I'll solve for x now, adding 12 to both sides. So I have positive 12 equals 7 over 11x. And I'll get rid of that 7/11 x by multiplying by the reciprocal, keep, flip, change, invert and multiply, whatever you choose to use, and I'll do that on both sides. Okay, I need to keep the equation in balance, and that allows me to cancel out everything on the right side except the x. So x equals, now 11 times 12 is 132 over 7. So I need to find out what 132 over 7 is as a mixed fraction. 7 goes into 132 18 times, with 6 as a remainder, so 18 and 6/7. Now, every time you have a fraction where it's over a 7, the the quotient will be an irrational number. In other words, it's going to go on and on and on and on and on, never repeat. And so we have to approximate the decimal. And so I'll save you the math here. The decimal approximation is 18.9. So that wavy little equal sign, that means approximately equal to. And so we'll say this is the x-intercept. Okay, the coordinates of that intercept are approximately 18.9 on the x, comma, 0. For all practical purposes, we can put the dot pretty darn close to 19. Let's go back up here. So I want to count over 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now back off a little bit because you want to be at 18.9. So like right there. Now we should be able to lay our ruler down and see, you see it? They all pass through, all 3 points are on the ruler. So it's pretty gangster to put a ruler down and see it passing through 2 points, but if you can make it pass through 3 points, and you've drawn a really good graph. Okay, so I'm going to draw this line now. Okay, so there's my line. And we'll make this bigger now that we have it plotted. So this is point 2 here at 11, comma, -5. And the x-intercept, x-int at, and here I'm going to leave it as an improper fraction, 1/32, comma, 0. All right, so we've done a full turn of the wheel. The only other thing I need to do is write in y equals 7/11x minus 12. We label the line, all right? So we now have everything on the graph. I guess I should write that this is 0 here at the origin. We have everything on this graph. So you have taken, this is the whole learning standard here in one problem. We took a slope-intercept form equation of the line, okay? We identified the y-intercept. We use the slope to find another point on the line. We then used our knowledge of algebra to solve for the x-intercept. We drew a graph from nothing. We plotted the y-intercept, the other point that we found, and the x-intercept, and we saw that all those points lined up. We drew a line passing through all 3 points. We labeled each point, and then we labeled the graph itself. So those were all the steps that we have to follow to do this. And what I'll probably do, because this has taken 33 minutes, what I'll probably do is teach this part one day in class, okay, because I would have given you 10 or 12 minutes to do those warm-up problems on your own, and we'll be out of time. And then tomorrow, or the next day in class, what I'll probably do is do this guided practice, okay? So I don't know if I'm going to save this for another video or not. I think I will. I mean, there's no reason to just keep forging ahead. I think I'll call the video there at 34 minutes, and we'll just pick this part up. This will be the guided practice for this unit lecture here. We'll pick this up the next day. So let me show you what we did here. So this was where we finished for today. We drew our graph. We did a full turn of the wheel. Good job. We labeled all this stuff and completed that matching exercise. We learned how to find another point given the slope and the y-intercept. And we did our warm-up activity here. Okay. Good, good. It was good. So thank you so much for watching. Please make sure to check the link, the pinned comment, link in the description for full video notes. And if you haven't already, please subscribe to this channel and hit that notification bell. Give the video a like. You know, I mean, if you watch this video and it helped you, please give it a like. It's supportive. And I really look forward to teaching you that guided practice in the next section and moving on with algebra from there. Thank you.